order of operations is a very important concept for both pre-algebra and algebra because it's a set of rules that we must follow when we're solving equations and inequalities. Now, last year and the year before, you probably heard about order of operations and you probably heard about something to remember it by called Pemdas, P-E-M-D-A-S. And some teachers have us remember, please excuse my dear Aunt Sally, as a way to remember this. Well, we're going to use a different acronym called GEMS, G-E-M-S, instead of PEMDAS, and I'm going to explain the two main reasons why. And before I explain those two main reasons, I'd like you to go ahead and copy down what GEMS stands for. And G stands for grouping symbols. And grouping symbols are things like parentheses, okay, so parentheses that look like this. But we also have brackets that are more square. We also have these lines that are called absolute value, and even the division line, when we have complex expressions on top and bottom, will be a grouping symbol. So here's the first main reason that we're not going to use PEMDAS anymore is because in PEMDAS, P stands for parentheses, and because we're getting into more complicated math, we're going to have more than just parentheses. As I mentioned, brackets, absolute value, and even the division symbol. The E stands for exponents. That hasn't changed. That's the same as it was in PEMDAS. And the M stands for multiply and divide from left to right. Now this looks pretty similar to what we had before, but the problem is that when we write PEMDAS like this, it looks that we have to multiply and then divide, and that's not true. It depends on what comes first when you're reading an expression from left to right. So for example, if I had the expression 10 divided by 2 times 5, I'm actually supposed to work from left to right here. So I would do 10 divided by 2 first, which is 5, and then 5 times 5 is 25. If I was following PEMDAS and did the multiplication first, 2 times 5 is 10, and then did the division, 10 divided by 10 would be 1. I would get a completely different answer. And subtract and add from left to right, very similar to the last one that we just saw, but this is another reason that, again, we're getting rid of PEMDAS, because PEMDAS, it looks like we have to add first and then subtract, and that's not true. It's whatever comes first when we're moving from left to right. So this is just a quick explanation, a review of some things that you've probably already learned, and that is that a power is a product formed by repeated multiplication of the same base. So here's a power. This whole thing is called a power, 3 to the 8th. This whole thing is an example of a power. And it's got two different parts. It's got the 3, which is called a base, and it's got the 8, which is the exponent. Some people use these two words interchangeably. They say power or they say exponent, but they mean the same thing. But what this means is that this base, 3, is being repeatedly multiplied a total of 8 times. So there's one, oops, excuse me, let me erase that. 1, 2, 3, 4, 5, 6, 7, 8. No, I'm not going to ask you to do this type of calculation. If I did, I would let you use a calculator. I'm more interested in knowing that you understand 3 to the 8th power means that there will be a total of 8 3s being multiplied together. Evaluate the expression. Well, before we can begin talking about what evaluate the expression, how I'm going to do these problems, I actually need to talk about the word evaluate. So here's a definition for your notes. Remember, you can pause these videos at any time. Evaluate means to find the numerical value of an expression. It basically just means to find the number answer. So go ahead and pause if you need to before I head back to this screen. So I'm being asked to evaluate. I want to know, what is the answer to this problem? I'm going to come up with a number answer. And I want to know here, what is the number answer to this problem? So that's what evaluate means. Well, now we need to know what the word expression means. So evaluate the expression. Here's another definition for your notes. Expression is a combination of numbers, variables, and operations without an equal sign. Please make sure you make note of the importance of this word here, without an equal sign. Here are two examples of expressions. You'll notice that neither of them has an equal sign. If they had an equal sign, they would be called an equation. It would be different. So an expression is a combination of numbers, variables, and operations without an equal sign. And we should probably talk about what the word variable means as well. One more definition for your notes. Variable is a letter that is used to represent a number. So in the expressions that you see down here, A is variable, B and C are variables, and I see those same variables again over here. So a variable is a letter that is used to represent a number. All right. Let's head back to this page where they were asking us to evaluate the expression. Well, I've got my question here. It's an expression, not an equation. And I'm going to jot down those 4 letters, GEMS, and use them like a checklist to guide me through this problem. I first check to see if I have any grouping symbols, and I do. They're right here. So I need to do what is inside these grouping symbols first. 7 plus 4 is 11. So I'm going to write 11. And then I'm going to copy everything else right underneath it, and I'm going to make a check mark here. I've done my grouping symbols. Now I'm going to look for exponents. Are there any? Yes, there's one right here. 11 to the second power is 121. And I'm going to go ahead and copy everything again. M stands for multiply and divide from left to right. I don't have any multiplication or division, so I'll go ahead and check that off. S stands for subtract and add from left to right. I do have subtraction. In fact, that's all that's left. So I can then go ahead and finish this problem by subtracting. I usually count up. You will see this in class. I count up. 121 plus 9 is going to give me 130. 70 would give me a total of 200, which must mean my answer is 179. Let's move over here to this expression that I need to solve as well. I'm going to list my order of operations again, GEMS. Do I have any grouping symbols? Wow, yeah, I do. And this again, here's a reason we switched from Pemdas. P stood for parentheses. We don't only have parentheses anymore. We're in a pre-algebra class, so we're going to see some brackets like we have right here. So when you have more than one set of grouping symbols, you find the most inside, which is right here. So I need to do 4 times 3 first because it is the most inside. And then I'm going to go ahead and copy everything else that hasn't changed. And my grouping symbols are done. I check for exponents. I don't have any. I check for multiplication. Nope, I don't have any of that left either. And now I've got some subtract and add. 15 take away 12 is 3. And then I've got my plus 8, which is 11. So my answer all the way down here in the bottom will be 11. Evaluate the expression when x equals 3 and y equals 5. Well, now they are giving us an assignment. They are saying, when you see these variables, x and y, every time you see them, you're going to plug in these numbers. So for the rest of class, for the rest of the year, whenever you have a question like this that is asking you to evaluate, and then they give you something to plug in, you're going to hear me ask you to use bubbles. Bubbles look like this. All it is I'm rewriting the problem, but instead of using the variable, instead of using the letter, I'm replacing it with a bubble, which is actually just an empty set of parentheses. So instead of writing 4x minus 9, I'm writing 4 bubble minus 9. On this problem, instead of writing 4y, I'm writing 4 bubble divided by bubble plus 2. And here I'm going to write 3 bubble to the second power plus bubble plus 2. Now I have room to go back and fill in every time I see an x, the number that's going to go there is a 3. Here's an x, so that should be a 3. Here's an x down here, that should be a 3. And here's an x right here, that should be a 3. And then I need to go back and I need to fill in all of the y's, should be a 5. Well, here's a 5 right here, and here's a 5 right here. On these 3 problems, I would like you to list the order of operations, GEMS, and I would like you to go through and solve these 3 problems using the correct order of operations. Here's a website for you to go to. It's a Who Wants to Be a Millionaire type game that will ask you about using the order of operations. tinyurl.com/carnes gems.